Howdy, welcome to Be the Packet. So you think you'd like a career in data networking? Well, I think this is a great place to start. To truly understand data networking, you have to start with the basics and learn how to count. I'm not talking about counting the traditional way of 1 through 10 and so on. You already know how to do that. Today, you'll learn how to count with the same system computers use to communicate, the big, bad, scary binary number system. Yeah, no, it really isn't all that scary. Stick around and see. I've been through the Cisco Networking Academy's CCNA and CCNP programs, and I watched other students wrestle endlessly with binary numbers. Sometimes other students asked for help, and during our open lab times I helped them. I found sometimes all it takes for a person to understand something is to have it explained to them in a different way. Textbooks and course materials tend to overcomplicate and sometimes give so much unnecessary detail it actually makes a subject more difficult to absorb. I'm going to do my best to unravel the mysteries of binary with simple, easy to understand explanations. So let's jump right in. What is binary? Well, binary is a number system. It's just another way of counting. That's really all it is. Binary is also the very basis of all things computer and data networking related. Let's start with the basics and look at how counting works. A quantity is represented by a number. As the quantity increases, so does the number. Different counting systems represent the quantity in different ways, but they all do the same thing. The counting system you use on a day-to-day basis is the decimal system, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. There are 10 discrete numbers, 0 through 9. Because there are 10 different numbers available, decimal is also called the base 10 system. Binary and decimal both do the exact same thing, they just look very different. Binary digits, which by the way are called bits, have only two possible values, 0 and 1. Because of that, binary is the base 2 system. Remember how in the base 10 or decimal system, when you move a position to the left, the value of that position increases 10 times? In the base 2 binary system, each time you move left, the value doubles. So starting from the first digit on the right, the first digit's maximum value is 1. The digit to the left has a maximum value of 2 times 1 or 2. Move left again and the maximum value is 2 times 2 or 4. Then 2 times 4 is 8. 8 doubles to 16, then 32, 64, 128. If this was a larger number, it would just continue to double moving to the left. So now let's look at an 8-digit or 8-bit binary number. This is something you'll probably be doing a lot of in the data networking field. You'll need to practice it until you're good at it, but eventually you'll just be doing this without any problem at all. Let's start with the binary number 111-00111. We'll separate the bits and write the values in each position. To calculate the value of the binary number, wherever the bit is a 0, make the value of the position a 0. Now all you need to do is add the remaining positional values. So the total is 231. See, you just did your first binary to decimal conversion without even realizing it happened. Let's do a couple more, then we can move on to converting decimal to binary. Next up is binary 10101010. The process is exactly the same. Write the bits over their positional values. Where there's a binary 0, change the positional value to 0. Then add the remaining values. Binary 10101010 equals 170 in decimal. Okay, last one. We'll use binary 01001101 this time. Write it out. Change the positional values to 0 where there's a binary 0. Then add the values for a total of 77 decimal. I think by now you probably have a pretty good grasp on what a binary number is and how to convert to decimal. If you practice this for 10 or 15 minutes a day, it won't be long until you don't need to write it out. You'll be able to convert to decimal in your head without any problem. There are resources on the internet to help you practice, and I'll drop some links in the video description. So well done. Now let's move on to converting decimal numbers to binary. That's a bit trickier, but once you get the hang of it, it really isn't difficult at all. Okay, it's time for me to shamelessly beg for subscribers. Please remember to like, subscribe, click the notification bell, and share this video. Okay, so moving forward. To convert decimal to binary, you only need to know how to add and subtract. This conversion is one that most people find easier to learn by watching, so let's get started straight away. I'll begin with a relatively easy decimal number, and it's one you've already seen, 170. Start off the same as converting binary to decimal, with the positional values written out. When converting to binary, start from the left. In this case, it's position 7, and its positional value is 128. Let's look at the number we're going to convert, 170. Is 170 greater than or equal to 128? Yeah, it is. So what we do is put a binary 1 in that position and subtract 128 from 170, and that leaves 42. Now move a position to the right. Is 42 greater than or equal to 64? No, it's not. Put a 0 in that position, keep your 42, and move to the next position. That position's value is 32. 42 is greater than or equal to 32, so put a binary 1 there. Subtract 32 from 42, and you're left with 10. Moving again, 10 isn't greater than or equal to 16, so a binary 0 goes there, and we move to the next position, which is 8. 10 is greater than or equal to 8. Subtract 8 from 10, that leaves 2. 2 isn't greater than or equal to 4, so a 0 goes there. Now next, 2 is greater than or equal to 2. In fact, it's exactly equal, so put a binary 1 there, and 2 minus 2 leaves 0. If you get to 0 before you get to the last position, you just change everything that's left to binary 0. Now you have the number 10101010 as the result. And here's a tip. When converting binary to decimal, you should always reach exactly 0. If you don't, you made a mistake somewhere. You can verify you've converted the decimal number to binary properly by simply converting the binary number back to decimal. That result should be the same number you started with. If it isn't, double check your math. Let's do a couple more decimal to binary conversions. We'll use 240 this time. 240 is greater than 128. Put a 1 in that position. Subtract 128 from 240, leaving 112. 112 is definitely bigger than 64, so put a 1 there and subtract 64. That leaves 48, which is larger than 32. Put a 1 there also and subtract 32. You have 16 left, and 16 is equal to the next position. Put a 1 there, subtract 16 from 16, that leaves you a 0. All you have left to do is set the rest of the digits to 0. That gives you the binary number 11110000. Okay, one more, then I'll leave you to practice on your own. 123 is your next number to convert to binary. 123 is not more than 128, so a 0 goes in the position on the left. 123 is larger than 64. Put a 1 there. Subtract 64 from 123. You have 59 left. 59 is bigger than 32, so a 1 goes there as well. 59 minus 32 is 27. 27 is greater than 16, so put a 1 there. And subtract 16 leaves you 11. You can subtract 8 from 11, so put a 1 there. You've got 3 left. You can't subtract the 4 from 3, so that gets a 0. You can subtract 2 from 3, you've got 1 left, put a 1 there, and a 1 in the last position. Now you're left with exactly 0, just as you should be. You should practice these on your own, but stick to numbers less than 256, so 255 or lower. That'll keep you to an 8-bit binary number, which is what we've been working with so far. Keep practicing until you're comfortable doing this. When you take a certification test, you should be accurate with these, but you should also be fairly fast because you don't want to cheat yourself out of any time on that test. In this video, you learned what the binary number system is and how it works. You also learned how to convert back and forth between binary and decimal numbers. Binary is very commonly encountered in the field of data networking, but there's another counting system as well. In the next video, I'll go over the hexadecimal system. You've probably seen it before as a number such as A8, CD, 51, BF, E3. You'll see hexadecimal quite frequently when you work with any kind of computer network. Don't worry, hex isn't hard either. You'll quickly see how knowing binary helps make hexadecimal a breeze. Thank you for watching this Be the Packet video. Remember to like, subscribe, and click the bell to get notified of new videos as soon as they're available. Ciao, and may all of your bits flow smoothly.